Stacks and queues. When we're talking about stacks and queues, this is the way data is stored and retrieved. If we just look at this diagram, graphical representation of what a stack is. So we've just finished with a plate, there it is there, and we wish to stack it. Let's have a look. We call it last in, first out, because when we are finished with that plate, we stack it, but we're too lazy to clean the rest. So what we do is we say, oh, we need a plate, and, oh, by the way, that adding to the stack is called pushing it on top. Stack is getting really high now. We push it onto the top, and then now we want to pop it, or take it off because we want to use it. So let's just go through that again. Push means we add it to the top, that's push, top of the stack, and that was the last one in. Now we're hungry again, we need another plate for food, so we pop it out of the stack. Now the best way to view this programmatically is with a function, a recursive function, and this is getting the console to write the factorial, for example, of 5. If we just have a quick look at how that runs, here is the factorial of 5. Note the parameter in our program module, in the actual program part, that parameter, the value 5 within the parameter, is going to be passed back to n. And then the function is going to do something with n. Let's run that to see what happens. Right, the answer is 120. What's happening? 5 is being passed back, and it says 5 minus 1 times 5. So 4 times 5 is 20, and the value 20 gets passed back to the parameter, and that 20 gets passed back again. So now we have 3. We have the previous number was 4, so it's 4 minus 1, which is 3. 3 times 20 is 60, and then 2 times 60 is 120, and then 1 times 120 is 120. So a typical example of a stack is a function, which is recursive. So a great way to show this, because there's the 5 being passed back to the function backwards and forwards. You can't see it on your screen, but the condition is if it is less than or equal to 1, then just simply return 1. And that's our get out of jail clause. That's our quick exit, our condition to get out of this recursive function. Here's the code presented to you to see clearly. There's our condition, but this is what we're interested in. This is how to recursively get the result of factorial 5. So it's 5, 4 times 5, 3 times the answer of that, 2 times the answer of that, and 1 times the answer of that, resulting in 120. So 5 gets passed back to our function. 5 minus 1 is 4, 4 times 5 is 20. Now we have 4 passed back, which is 3. 3 times 20 is 60. Then we have 2. 2 times that is 120. And then we have 2 minus 1, which is just 1. And 1 times n. So constantly n is being passed the new value after our method has looped until it reaches 1, and then we exit. So a great way to show how stacks are used to store the return address, parameters, and register contents when a function call is made. That's our function call. So when the procedural function completes execution, the return address and other data are retrieved from the stack. So if you can imagine us stacking our values that keep changing due to our little method we've set up here, our little calculation. Now stacks are also used when dealing with reverse Polish notation. This is an ideal example to explain stacks and how important it is in creating the tree. So we are pushing down all the way to the very last. No, let's just do that again. An ideal example of how stacks are used is in our reverse Polish notation. So pushing and popping, how does this relate? Well, you can see that we end up with our very first at the top, but actually this represents the last thing we need to do. So we've pushed all the way down, and now we're going to start popping all the way up. And we've got to do our 4 plus 5, multiply that by 6, subtract 25, and then divide 2 plus 3. So you can see completely here, if we were to come across a question about stacks and reverse Polish notation, what is it about stacks that relates to reverse Polish notation? Well, you're pushing, adding to the tree all the way down, and you end up with the most important conclusive operator at the top of the tree.